Okay, 2.10, we're doing adding derivatives of tangent, cotangent, secant, and cosecant. So before we do so, let's remind you how these functions are related to sine and cosine. So for cosecant x, that is the reciprocal of sine. So that's the same as 1 over sine x, which is useful for evaluating it, for calculator, for everything. Secant is the reciprocal of cosine, not the opposite, reciprocal. Tangent can be written as sine x over cosine x, and then cotangent is the reciprocal, so it's cosine x, okay, over sine x. Okay, the derivative of sine is cosine, we already know that. Derivative of cosine is negative sine. Okay, so these are some derivatives we're going to add. You will memorize these eventually, but I'll show you how to derive them until you do have them memorized. So the derivative of secant x is secant x tangent x. The derivative of cosecant x is negative cosecant x cotangent x. Derivative of tangent x is secant squared x. Derivative of cotangent x is negative cosecant squared x. And if you'll notice, all the ones that begin with a c, their derivatives are negative, because that's going to help you remember which one is which. Okay, now that we derived those two, you should be able to get the other two if you want to check it, or if you ever just blank out and can't remember the derivative. So let's go ahead and take the derivative of these functions now that we know some other things. Okay, find the derivative of y equals x squared tangent x. Okay, x squared tangent x. This looks like product rule. Okay, so take the derivative. So instead of y prime or dy dx equals, okay, product rule. First one, derivative of the second one. The derivative of tangent is secant squared plus. Okay, now I'm going to take the derivative of the first one. I'm going to leave the second one alone. So the derivative of x squared is 2x. And I'm going to leave the tangent x alone. Now, does this simplify? I mean, I could factor out the x, but it's not going to make it better. So I'm going to go ahead and leave it like this. They're not like terms. That's a good answer. Okay, let's try example 2. It says find f prime of pi over 6 if f of x equals secant x. So I'm going to go ahead and take the derivative of secant x. The derivative of secant x is secant x tangent x. Now let's plug in pi over 6, and it should be done on 2 separate steps. So the secant of pi over 6 times the tangent of pi over 6. And this is mostly to see if we remember our trig. What is secant? Secant is the reciprocal of cosine. What is the cosine of pi over 6? The ordered pair for pi over 6 is what? Root 3 over 2, 1/2. Cosine is the x coordinate. So if I do the reciprocal of root 3 over 2, I get 2 over root 3. Okay, what's the tangent of pi over 6? Tangent is the y over the x. So 1/2 divided by root 3 over 2. The 2's are going to cancel, so I'm going to end up with 1 over root 3. Does that seem okay? Okay, let's multiply this out and simplify it. So I have 2 times 1 is 2, root 3 times root 3 is 3, so f prime of pi over 6 is just 2/3. Okay, last one, we're going to use a calculator to estimate the derivative, which means don't do this by hand. We're 100% going to use my calculator. So I want to figure out g prime of 2. And for work, I can just write g prime of 2 is, I'm going to show you what I'm putting in my calculator just because these are your notes. But if you just write g prime of 2, that's fine. Because it depends on your calculator, some of your calculators you can input cosecant, some you cannot. I believe you can on the NumWorks and not on the TI. So if you're on the NumWorks, just try to enter it as you would. The answer is 1.2020. If you're on the TI, you're going to take the derivative, and since there's no cosecant button, I need to rewrite this as 1 over, I want to do sine squared, but my calculator is not going to do sine squared, so I need to do the sine of 4x, and then I need to square that quantity, and then I want to evaluate it at x equals 2. Okay, I'm telling you that the answer should be about 1.2020, and you're going to play with your calculator and see if you can get the answer. You might have to change your parentheses, your squareds. You might be able to input derivative of this directly, and that should give you the correct answer, but try it. Try to leave 4 decimal places, please. You can truncate or you can round. Okay, I'm going to show you how I derived 2 of them real quick so that you can see how you can get the answer if you forget it, and you can see that I am not making these up. Okay, I'm going to rewrite secant as 1 over cosine. I'm going to take the derivative of 1 over cosine. If you want the derivative of 1 over cosine, I could use the quotient rule. So let's do low, d high. The derivative of 1 is 0. Oops, not 1, 0. Minus high, d low. What's the derivative of cosine? Negative sine. Square the bottom. Away we go. Okay, if I do cosine x times 0, that turns into 0. If I do negative 1 times negative sine x, I get positive sine x over cosine squared x. Now I'm going to rewrite this because I know what the answer is on the other side of the paper. Okay, so I have sine x at the top. I'm going to split this into cosine x, because that's cosine squared x, and then I can rewrite this as tangent x. This is like 1 over cosine, so this is tangent x secant x. So the derivative of secant x is tangent x secant x or secant x tangent x. That's how it's derived. Are you going to derive it all the time like that? No, you're going to remember it. Okay, and then I'm going to show you cotangent just so you can see the other kind. So if I take the derivative of cotangent, I'm taking the derivative of cosine x over sine x. So I'm going to use the quotient rule. So that's low. D high, the derivative of cosine is negative sine minus high, d low, square the bottom, and away we go. Okay, so this is negative sine squared x minus cosine squared x over sine squared x. And I know that the answer is supposed to be negative cosecant squared x, so we're going to go with that. Okay, I know that sine squared x plus cosine squared x is 1, but this is negative, so I'm going to take out the negative. And then the Pythagorean identity tells me that sine squared x plus cosine squared x is 1, so this is negative 1 over sine squared x, which is going to equal to negative cosecant squared x, which is why the derivative of cotangent x is negative cosecant squared x.